So, hi everyone, my name is Peter, and I'm going to be today's presenter, and I'm going to talk about how bundling tools work under the hood. It's not a problem if you are not familiar with any of the tools with Webpack, Rollup, or Browserify. We are going to start from scratch actually. So the first topic we will explore is why do we actually need bundling tools and what are bundling tools? Let's see how we used to structure JavaScript code from the very beginning. A long time ago, when we had to develop some feature on the front end, we either put our JavaScript logic inside the script tag in the HTML, or we created one huge JavaScript file and put everything there, probably using jQuery or Vanilla.js. And this is actually the definition of the spaghetti code, where you have no separation of concerns. It's not testable and not reusable at all. So even on the front end, we had to evolve. And the next evolutionary step was the revealing module pattern, where we put our actual logic in a file. Let's say this is the calculator that can add two numbers. And we created another module that uses that functionality. And like that, we had at least some kind of structure in our code. But it was still bad, because as you can see here, the dependency is hard-coded, so we cannot really test this code. We need to have a manual list of dependencies, so if I switch index.js and calculator.js in the DOM, the code won't work. And imagine that if you have a couple of hundreds of modules, it's not that easy to know where to put the next one that you create. So it's like a dependency hub. And also from performance perspective, it's bad because every module is an extra HTTP request. So we backed the revealing module pattern with some server-side logic. That's a twig-like template language, but it doesn't really matter. The important thing is that instead of HTML, we had some kind of templating language where we specified what are the modules that we actually need. And on the server, those modules were concatenated into one big file, and that file was sent to the client. So instead of having HTTP request per module, we had just one HTTP request, but it's still the revealing module pattern with the hard-coded dependencies. So from performance perspective, it's a better approach, but it's still not testable, and we still have the manual ordering of dependencies. The next step that came is that we actually started to use some kind of module loaders. For example, async module loaders like require.js or system.js. Like that, we actually loaded require.js in the template, not our application, and specified what is the entry file for our application. And what require.js or system.js does, it knows that we need that module, so it will send an HTTP request and start to download our index module. It will see once it's actually downloaded that in order to run it, it needs to load its dependencies, the calculator. So it sends another HTTP request, loads the calculator, and then it can run the actual code. And like that, we still have this structure, so we have modules. It's much better from testing point of view, because as you can see here and here, we don't have the calculator hard-coded, it's being passed to the module. And regarding performance, it's slightly better than than the revealing module pattern without server side, because like that the modules are being downloaded, lazy loaded. So only those modules will be downloaded that are actually being used, not all of them. But still, every module is an HTTP request. And regarding the dependencies, we don't have a static list of dependencies. But if we have a big project, we still need to specify where the given dependency can be downloaded from, because it might come from CDN, it might come from our own server, so we still have a mapping between a dependency and its location. And if we check the next step, it's Node.js and actually the CommonJS module format. Here, there is a huge difference compared to all of our previous examples. What we can see here that here it's not actually getting the dependency with an HTTP request. It's a synchronous loading of modules, and it's getting it from the file system. So finally, with Node.js and with CommonJS, we could leave the browser and we could actually start thinking of modules as a file and can load them from the file system. And this code can be run from the CLI, so it doesn't require a browser to actually run this code. More importantly, this code won't even run in the browser, because the browser doesn't know what module.exports mean, and the browser doesn't know what require does, and doesn't know how to get ./calculator. So this code is not able to run in the browser. And a couple of years ago, when Node.js and CommonJS started to gain a lot of people and people started using it, of course the question rose on that: what if this code could run in the browser? And a couple of years ago, this question and this topic was the holy grail of JavaScript, because if we could do that, it would mean that we could share the code between the server and the client, and we could actually start building isomorphic applications. So if we can run a server-side logic on the front end, that means we have an isomorphic application where the code can run on the server and on the client as well. And that is actually bundling that solves this issue or answers this question. So let's see how bundling works. Let's say we have an entry file, a JavaScript file, this one, and it has some dependencies on the file system. What bundling does, it will get that entry file, and first it will load all the dependencies of that entry file, and then as a second step, it will generate one big JavaScript file that is an executable self-contained file. And if we do that, like that, we have structure. We still have the testability because we are using a module format, either CommonJS or the S2015 module format. And like that, we have a much better performance because it's one HTTP request for the entire bundle. And finally, we don't need to specify the list of dependencies or the location of the dependencies, because on the file system it's easy to find the modules. So this is how bundling actually works, or how it looks like. And now that we are familiar with the concept, we could actually implement our own CommonJS bundler. It's gonna be a very, very naive implementation, but still, what we are going to do now, we will make this code run in the browser actually. To do that, it's not that easy as it might seem for the first time, because we can see that the module that exports is just a JavaScript object, so it's nothing special. And The require is just a function. So if we provide our own module object and our own require function, then we can make this code run in the browser. Yeah, so this is what we are going to do. As a first step, we can convert this code to something like this. So imagine that you have a function which is get module dependencies that gets the entry file, which is the index.js, and it just converts it to an array, and the items of the array are the modules. For every module, we assign an ID to the module, we have its location, the source code, and the list of dependencies. So you can see that for the calculator.js, it has no dependencies. For the index.js, it has one dependency, the./calculator, and the ID of that dependency is 1. And we know which one is the entry file. If you are curious how to convert the modules to a structure like that, you can check out the module deps npm package that I linked